Hey guys, today I'm going to be taking a look at some YouTube malware. Sometimes when I'm bored, I'll go and search up keywords that tend to pull up malware videos on YouTube, like exploit, free game hack, etc. And when I was doing that, this was actually the top video. So this guy's channel apparently got hacked and has been pushing out malware for quite some time now. His last real video was actually a month ago, right over here, and then after that it's just been malware, just getting spit out since 3 days ago. Last upload was 4 hours ago. So yeah, let's go take a look at this and see what it is. It's purporting to be a Roblox script executor. I haven't played Roblox since like 2009, so I don't know what that is. But yeah, let's go and open Edge and a VM. Later. Okay. Go to site. This is a Huawei Penguin. Not sure what that is. Then we have whitewidow.zip. Sounds very suspicious. Okay, let's go extract all this crap. Password is PNG. Ping. And I can close that out now. And we'll go take a look at these two executables in CFF Explorer. So we have Gandalf White and Gandalf White 2, and they're both .NET files. So we can go and drop those in dnspy. We don't need this anymore. And we can go take a look. And it seems like the files have been obfuscated just by the amount of files I've looked at before. I can kind of guess that this is confuser.ex. I may be wrong, but I have a d4 fork that automatically can handle vanilla confuser.ex files. So if they didn't modify the source of confuser.ex, it should deobfuscate fine. So I'm going to go ahead and drop both these into d4. Just taking a look at the video. Yeah, it looks like it was able to detect confuser.ex and deobfuscate it. I had just been looking at the video because I was curious why oh, there it is. It says if it doesn't work, if v1 doesn't work, then you do v2. Files are named differently in the video though, but yeah, we should go take a look and see what the difference between v1 and v2 is. Is it really just the same file? Here's the deobfuscated version, so let's see if it deobfuscated it properly. So it looks good. We take a look at this class 6. It seems to be combining the path of the application data folder with this d3d9.dmm. And it is replacing the M's with L's, so it's DLL. And then it is calling smethod2, which simply checks the file exists, and if it already exists, it will delete it. Then we have this smethod3, which just decrypts the byte array, which is in class 5. Then we have smethod4, which writes all the bytes to the disk and then sets the attributes of the file to hidden. And then we get a load library call here, and then it calls the export Huawei share. And it seems to be, oh, actually it does look like it's the same. The file sizes, are they, let's check the, are these the same? They're not. That's interesting. Yeah, we'll have to see if these DLLs that get dropped are if they're the exact same or they actually differ. So we're going to put a breakpoint right here, or sorry, right here, load library call. We're going to run that, and then we're going to go to our app data, and then we see d3d9 DLL. We can actually end execution there. D9, do this one.bin. And then we can also run this one and do the same thing. Put a breakpoint here. All right, we have the D3, D9, 2. So let's D3, D9, that. They're actually different sizes, which is interesting. Excuse me. So now that we have these files, we can actually see that it's not passing any parameters when it calls the export. So that is a good thing because it means we don't have to touch this file anymore, those .NET files. So what we can do is we can go and move both of these onto my own personal, the host machine, so I can put them in IDA, because I do have IDA on here, but I'd rather just take care of it on my host machine. So we'll go to unknown. We'll put those right here, and we're going to go and pop them in IDA. I'd actually looked at one of these from last night, and they the threat actor updated the download, so it must have gotten detected. And this looks like OLLVM, which is an obfuscator, and this is control flow flattening, and it also has another pattern, which is I've seen before, which are these D words, kind of XOR operations going on. But yeah, this function, this entry point function, actually doesn't call any other functions, so we can ignore that. What we're really focused on is this Huawei share export, and I'm just going to warn you not to go to that export while you're in the decompiler, because it is so heavily obfuscated it will freeze your IDA for like 5 minutes. So I'm going to go to it in here. So can I do it this way? Sure. Yeah, thank God I went through here, because look, it can't even display it on a graph mode because it's so big, unless I guess you change it. But yeah, this function is huge. Go back to it. Yeah. Go slowly. What was that there? Come on, you're scrolling so... Nope, that's nothing. You know what? This is too big. Let's just look in the imports, see if we see anything interesting. So we have write process memory. That's peculiar. Where's that being called in? That is being called in the Huawei share method. It's called several times. What else do we have? We have virtual alloc X. That's also in Huawei share. We have read process memory, which is also, yeah, all these are in that export. And then we have set thread context. I'm guessing there's a get thread context. Yes, there is. And take an educated guess and assume this is process hollowing. So what we're going to do here is, yeah, they even have the resume thread, and it's okay. So what we're going to do is go and I'm going to open this in X6 or X32 debug, and we're going to take a look. This is, I opened D3D9. Yes, this is the first one. Okay, so we go to options, preferences, and we're going to do user DLL entry. So let's break on the entry point, and I'm going to go, and you know what base address is this? Actually, you know what? Change the plans. Let's go and pause execution, or stop execution. I'm going to go to here, opening CFF Explorer. I'm going to disable relocations on here, so it goes at the same address. So I'm going to overwrite that. Probably should do the same here. Oops. To this one. Oops, that's not what I meant. Here, overwrite original file. Then we can put this back in here. Go right here. And then go Huawei share, copy that, go there, gonna set the EIP here, and I am gonna go and put a breakpoint on, let's say, right process memory, for example. Let's go here, put a breakpoint there, and we will run it. Hit the breakpoint, and we can see what the third parameter is. Let's follow that in the dump. That looks like a PE file. So what we're going to do is we're going to go to the memory map, and we're going to dump the .data section. So we'll dump memory to file. We're going to name this 291 dump.bin. And I'm just going to, I'll just stop execution. And then let's do it to the other file. I actually haven't checked if I haven't actually checked this in IDA, but I'm going to do it. I'm just going to do the same procedure anyway, and hope that these files behave the same. And I am actually not entirely sure they are. I probably should check. Before, you know what? Let's just check it in IDA to be safe. Let's go here and yeah, the imports seem to be the same here. Yeah, okay. You know, we'll go here to Huawei share. I don't want to accidentally open it in. Yeah, here you go. Okay. Would have had to open an IDA anyway to get the right address to switch up the execution to, but let's set EIP here. Oops. Failed to load DLL. Strange. Oh. Good old Windows Defender turning itself back on at the most inconvenient times. Yeah, this is wrong. It's not Llama Stealer. Unless they updated the payload, then it might be. But I had looked at a variant of this last night, and it was not Llama Stealer. So let's try debugging this again without Windows Defender messing with us. And we will go to here, set EIP, and then we'll go to write process memory, go to value. Oh my god, please go away. Got a breakpoint on here, follow and dump. Got another PE image, so let's go to the memory map. We're going to right click, follow memory map, and dump the data section. So we'll do dump memory to file, to dump. Let's see if these files the same. I'm about to find out. Hashes. No, they are not the same. I think they're probably just the same payload but obfuscated a second time. So let's see. So let's actually make sure we actually dumped it properly. So I'm going to put both these in here. We have .NET PE files, but they're different sizes, different names too. So we're going to take a look at both of them. So we got Bogox and Leave. Let's see. This trying to see if I recognize this malware. Looks like it has obfuscation on it, but I don't know if, I don't think that's Confuser EX. Yeah, this, I don't know. I think this, I'm going to take a wild guess and say this is Agent Tesla. But what about this one here? So this looks like Redline Stealer. Here's a Discord Stealer. So this Bogox is the one I'm not sure about. It's strange, they actually did include two different binaries that have completely separate payloads. Is this an obfuscated version of Redline? Well, I am too lazy to find out myself right now, so I'm just putting all of them on VirusTotal. So we'll see where that goes. I'm actually putting all these files on there, so if someone downloads them in the future, they don't get, hopefully, don't get infected because they're already detected. So we're about to see what this. You know, actually, I could have put this in d4 dot. I'll do it in a second. Okay. So I'm gonna put no, you can't upload multiple files on here, can you? Putting this one. I'm gonna put a new tab and do second dump. Oh, and actually, you know, now that I think of it, since I dumped the entire .data section, there's no way they'd the hashes would be the same anyways, unless maybe if I truncated the files. But yeah, that's now that I think of it. But the files are different anyways. We already checked. But even if they were the same, okay. So this one's Redline, but I think we already knew that question. Oh, they're both Redline, are they? Is this just obfuscated? Let's see. In d4 dot, which is the obfuscated one? It is Bogarx, which is the first dump. So we're gonna put that first dump in there, and I don't even know if it will be able to deobfuscate it. To be honest, I kind of doubt it will. Yeah, I don't think this is gonna. Yeah, no, I wasn't able to. Alright. Do they connect to the same? I could write a deobfuscator later for that. But currently I'm working on a deobfuscator for a different tool. I'm just gonna wait here and see if it says what addresses it's connecting to. Behavior. Does it connect to a CNC? It's a little frozen there. Well, I didn't intend the video to go this long, but I was just curious. Oh, wait, nope, there's the 6 IP addresses. Are any of these flagged? What is this one? Here. Yeah, that one's malicious. Let's see. This one, sorry about that. Yeah, both these are malicious, but yeah, they seem to be completely different files. I wonder why they did that. It's like pick your poison, right? So yeah, I'm not gonna bother to try and deobfuscate this. If you go on my GitHub, I do have an article about deobfuscating an agent Tesla sample by manually rewriting or manually writing a deobfuscator for it, but I wasn't even considering the fact that I might have to do that with this, so I'm not going to. I should have a new article though coming on my website about deobfuscating a native file. So yeah, thank you for watching, and I'm gonna go upload the rest of these samples to VirusTotal.